Welcome to another class with Math Academy, and today we'll be learning some important differentiation formulas. These formulas are used when differentiating expressions, and it is very important you understand and know these formulas at the back of your palm so that it makes differentiation very easy and simple for you. So today we'll be learning these formulas, where to use it, how to use it, and we'll also be looking at some examples on how to use these formulas. So stick around and let's dive right into the formulas. Welcome back. So number one formula we're looking at is when you are differentiating a constant. So if you have, when you're differentiating a constant with respect to x or with respect to anything you're differentiating to, when you differentiate the constant c, you get 0. So this means if you're asked to differentiate a constant, let's say 5, you'll have something like 2x squared plus 5. If you're asked to differentiate this simply means let's invoke the constant formula. So I'll be differentiating only 5. Okay, so if I'm to differentiate this 5, this is this over the x. So if I'm to differentiate just 5, what this simply means is if I differentiate this, we have 4x, and then this is going to be plus. Now we differentiate this constant, we have 0. So whenever you're differentiating a constant, you're going to have 0. So let's look at the second formula when differentiating. The second one is the power rule. So this is when differentiating a constant. Let me put it this way. Let's see the uses. Let's outline the uses. Number one is when differentiating a constant. So number 2 is called the power rule. So this states that d over dx, when you have a function to the power of n, it is equal to nx n minus 1. So this is called the power rule. Alright, so let's use this part to do a little bit of explanation. So for example, let's look at number 2 example. You have, let's say, still the first rule we use, the first example we use 2x squared plus 5. So if I'm asked to differentiate this means I differentiate 2x squared plus I differentiate 5. So using the power rule simply means whenever you have a power to a function, so this simply means here our 2 is n. Let's look at this again. 2x squared is like x to the power of n, so the whole of this is now our n. Sorry, it's not our x rather. So this is our x, and the whole of this is our n. So what does the rule say? When you have a function that is x and the power is n, to differentiate it, it means nx to the power of n minus 1. That means use the power to multiply the function and then subtract 1 from the power. So that's simply, it's going to give us, our n is 2, so this is going to be 2, and then this is going to be our x. This is going to be x, and n is 2 minus 1. So remember there was a 2 here. There was a 2. So this is going to be 2 multiplied by 2x. It's going to be 4x to the power of 2 minus 1 is 1, which is same thing as saying 4x. Alright, so whenever you have function to the power you use the power to multiply the function, and then you subtract 1 from the power. So that's just the power rule, and that's how you apply the power rule. Let's look at the third function. Remember, these functions, these formulas are very, very important. You should master them and know how and where to use them. So the third one we'll be looking at is what we call the linear function. So if I have a function like this is a linear function, ax plus b. What that simply means, it is equal to a. That is, when I'm differentiating a function like this with respect to x, that simply means my answer is going to be a. This is called a linear function. The fourth one we're going to be looking at is what I call this is a trigonometric function. We'll be looking at some trigonometric functions. This is just one of it. That is when you're differentiating sine x, a function sine x. So what you get is cos. When you differentiate this sine x, what you get is cos x. So this one is a trig function. That simply means whenever you're differentiating sine, you get cos. How about if when we are differentiating cos? So assuming we're not asked to differentiate cos, what we get is negative sine x. This is also a trig function. Okay, so number 6, when we are to differentiate another trig function, if we have a trig function tan x, it's also a trig function. So what we get is sec square x. This is sec square, which is what they call the secant square x. So this is 5. So this is number 6. It's also a trig function. That's when you use it. Whenever you want to differentiate tan x, you get secant square x. I've made several videos where I differentiated trig functions. If you haven't seen those videos, just click somewhere up right there. You're going to see the video where it's going to link you to solutions. I differentiated different kind of trig functions, so you're going to see how those functions were differentiated. So you can watch those videos to gain more knowledge on how to use these trig functions. Alright, so let's look at the 7th one, also a trig function. If we have differentiating cot x as a cotangent, so if you're differentiating cot x, what you have is negative so this is also a trig function. This is number 7, which is also a trig function. Now, like I said, we'll be looking at so many trig functions. How many trig functions have we gotten now? 1, 2, 3, 4, 5. Okay, so let's look at number 8. If we have a function as d over dx, and we have sec x, which is, if you differentiate this, what we have is sec x, it's going to be sec x tan x. also a trig function. So whenever you differentiate sec x, you have sec x tan x. And number 9, the best way to have all this in your memory is by constant solving, constant usage. So you have to constantly engage in questions that will lead you to apply this. That's the way it's going to stick to your memory, never to forget them. So keep practicing question examples that will lead you to using these formulas. So the 9th one we want to look at, if you want to differentiate, let's say cosecant x, which is abbreviated as CSC. CSC is just simply saying cosecant, so just abbreviated as that. So if we are differentiating cosecant x, what you have is negative cosecant x cot x, also a trig function. So if we're differentiating cosecant x, we have cosecant x cot x. Cot is just simply cotangent. Okay, so number 10, if you want to differentiate an exponent e to the power of x, it is equal to e to the power of x. This is an exponential function. And number 11, if you want to differentiate a to the power of x, what that means is a to the power of x ln a, as long as a is greater than 0 and a is not equal to 1. So as long as a is greater than 0 could also mean a is 1, but as long as a is not 1, that is, as long as a is not 1, it is greater than 0, then if you're differentiating that, you have a to the power of ln x. A to the power of x ln a, rather. So that's what you get when you differentiate a to the power of x. As I said, I have several examples where I have solved using these functions explicitly in some of my videos. You can just click the link right up there and it will take you to the videos where you can see how these functions are being used and applied. Okay, so let's look at the 12th one. If you have to differentiate a function as thus, you're asked to differentiate ln x. What that gives you is 1 over x as far as x is greater than 0. So what that simply means, if you're asked to differentiate, let's say a function as ln, let's say you're asked to differentiate ln 2x, what that simply means is 1 over 2x. Alright, so if we want to differentiate the 13th one, oh, by the way, number 12, you use that when you are having a logarithmic function. So number 12 is for, it's a log function, a log function. So whenever you differentiate ln x, what you have is 1 over x. As long as x is greater than 0. All right, let's go to the 13th one. If you have, let's say, you're differentiating, this is also a logarithmic function, log x to base a. What you have is equal to 1 over x ln a. As far as x is greater than 0, a is greater than 0, and a is not equal to 1. A is not equal to 1. So this only holds when x is greater than 0, your a is greater than 0, and your a is not equal to 1. So this is also a log function. All right, so let's look at the 14th one. Like I said, all these functions, logarithmic functions, you don't need to start memorizing them. The best way it becomes a part of you is when you have, engage in constant solving of examples that is going to make you apply these formulas, these differential formulas. Then it sticks with you and become a part of you. All right, so let's look at the 14th one. So let's look at the 13th one. So you have, when you're asked to differentiate log x to base a, what that simply means is 1 over x ln a. As long as you have that x is greater than 0, and also a is greater than 0, and a is not equal to 1. Number 14 formula, if you have d over dx to the square root of x, what this simply means is 1 divided by 2 square root of x. Again, as long as x is greater than 0, a is greater than 0, a is not equal to 1. So this is a log function. This is also a this is going to be a root function, not a log. This is going to be a root function. So let's look at the 15th one. I promised I'm going to give you 19. You just stick around. The 19th one is very, very important. So just stick around, go with me to the 19th one. 18th and 19th one, it's very important, and students mix this up. So I'm going to take my time to explain this 19th and the 18th one. So stick around and let's get to the 19th and the 18th one. So we got to the 15th one. This is when you differentiate a product of a function uv, where u is a function, v is a function, product of two functions. What that simply means is to differentiate it, what you do is saying u and then dv over dx plus v differentiate u over dx. So two functions, for example, you have 2x square, and then you have, this is 6x. So there's two functions. So this is going to be our u, this is going to be our v. So what this simply means is 2x squared, that's u. Differentiate the v with respect to x. So if I differentiate the v, what I have here is, if I differentiate the v with respect to x, what I have is 6. So this is going to be 6 multiplied by 6 plus v. What's our v? 6x. What's our du dx? So if I differentiate du dx, what I have is 4x. So this is going to be multiplied by 4x, and then I'll simplify this. And then I simplify this and get my final answer. So whenever you want to, differentiate products of two functions, you use this formula to differentiate it. So let's look at the 16th one. If you have a function like this, number 16, and this time around it's a function dividing each other. So this is called the quotient rule. So you have a function u divided by v. So this number 15 is called the product rule. So when you have a function, two functions dividing each other, you use the quotient rule. So number 16 is called the quotient rule. Number 15 is called, okay, let me put it this way. Let's do 15 first. Number 15 is called the product rule. And number 16 is called the quotient rule. So whenever you have a function dividing each other, what to do is you have to say v du over dx minus u dv over dx all over v squared. So whenever two functions are dividing each other, what to do is, this is the formula you're going to use: v du over dx minus u dv over dx all over v squared. Or this can be rewritten as so. Or we can rewrite this in this manner by saying, if you have u over v, differentiating it, first differential is going to be v, and then you differentiate u minus u, and then you differentiate v divided by v squared. So this brings us to the 17th rule of differentiation. If you've watched up to this 17th rule, a round of applause to you for taking your time to go through this. It shows that you are really hungry for knowledge and you really want to know these differential rules. And like I said, keep solving examples, look for questions, go on the internet. You're gonna see questions, just search for questions that will help me use the quotient rule. You can just type questions, differential questions that involves using product rule. You'll see different questions there. Try it, just use this formula, try it. questions that involves me using logarithmic function. You see questions, solve those examples. That way you become a master at it. All right, so let's look at the 17th question, 17th rule. This 17th rule is what we call the chain rule. Is what we call the chain rule. So the 17th one, you have, if you are to differentiate this, you have to differentiate a function f g of x So to differentiate a function f, g of x, these are two functions. The first function is f of x, second function is g of x. So these functions are, one function is inside the other. So this simply means that how to differentiate this is differentiate f, keep g of x, and then differentiate g of x. So you differentiate x multiplied by g of x, and then you differentiate g, the function g of x. So this is chain rule. I also have videos where I apply the chain rule. I'm also going to link it up there. You're going to watch. I'm going to put a link to all of these videos in the description. So you're going to see link to all the videos where I applied these rules, so you can watch them and understand them better. So this brings us to the 18th rule. Like I said, congratulations, you stayed up to the 18th rule, which I want to explain, which is called the inverse trigonometric function. So the 18th rule of differentiation, we call this the inverse trig function. We've learned some trig functions, but this is the inverse trig functions. So who can recall, if we differentiate sine x, who can recall what we're going to have? Yes, cos x. You got that right. A round of applause for yourself. And if we differentiate this, if you actually differentiate cos x, what are we going to have? Negative sine x. So now this is the inverse of what we've been doing. That's what we want to look at, the 18th rule. So the 18th rule is the inverse. So if you have the inverse of sine x, inverse of sine x simply means, this is what the inverse of sine x means. Inverse, that's 1 over sine x. So if you're asked to differentiate something like that, the inverse of sine x, this is how we're going to approach it. So what that simply means is, if you're asked to differentiate inverse of sine x, this is the inverse. So what this is going to give you is 1 divided by the square root of 1 minus x squared. So let's move to the 19th differential formula. So the 19th is also an inverse trigonometric function formula, where we want to differentiate the inverse of cos. So when you differentiate the inverse of cos, you get negative 1 divided by the square root of 1 minus x squared. If you recall, when we differentiated in one of the formulas, when we differentiated cos x, what we had was negative sine x. And when we differentiated sine x, what we had was cos x. So you can see this is just still the same thing. You can see when we're differentiating inverse of cos, we have a negative sign. Just like here, we had a negative sign. And then when we differentiated sine, we just had positive. Here we'll have it being positive. So take note, whenever you're differentiating a cos, there will be a negative sign attached to the differential function. So that is all we have today for differential functions, important standard functions you need to have at the back of your palm if you want to be a master in differentiation. If you know all these differential functions formulas, I bet you will be able to solve any differential equation you're given to. If you have any question or you don't understand any of these formulas, just put it in the comment section, the one you don't understand. I'm going to make a video solving a question using that differential formula so that I can explain deeper and better to your understanding. And if you have any question, differentiation, integration, feel free to drop it in the comment section. I'm going to make a video specially and I'm going to tag you. I'm going to send you a mail directly whenever I post that video. So if you've not subscribed to our channel, please do so. Like this video, give it a thumbs up, and click the notification bell so that you be among the first to get a notification whenever a video is dropped. Thank you so much for watching Maths Academy. See you in our next video. Bye for now.